Hello ladies and gentlemen, welcome to video 6 of what appears to actually be 7 videos for this particular section, which is Chapter 1, Section 3 of your McGraw-Hill Algebra 2 textbook. This section is entitled Solving Linear Equations. As such, this one section of your Algebra 2 book is reviewing an entire chapter and a huge, major chunk of what you're supposed to have coming out of Algebra 1. So this particular video focuses in on some questions that are worded like standardized test questions. SAT, ACT, and I-Step 10 are the tests that I'm referring to. So we're going to work through 3 examples here. I'm sorry, 2 examples, and then we're going to talk about literal equations a little bit. So here we go. Letter E. This example follows from the ones from the previous video. It says, what is the value of x that satisfies the equation below? That is a really fancy way of saying solve for x. That's all that's saying is solve the equation. Now you'll notice there are some decimals in here. Decimals are essentially fractions. You'll notice how we have 1 decimal place in each of these numbers. To get rid of that, what we're going to do is we're going to multiply each number in the entire equation by 10. So that's, we're going to multiply every term, 3.1x, 7, 7.4x, 1.5x, and 6 times x minus 3 halves. That's all one term, so it all just gets multiplied by 10 entirely. Now when we do that, the result is all of our decimals go away. We end up with negative 31x plus 70 minus 74x equals 15x minus 60 times x minus 3 halves. Now again, I didn't bother to clear the 3 halves from inside the parentheses because when I carry out my next step and I distribute that 60, that is going to eliminate the fraction. So we will have 31x plus 70, negative 31x plus 70, minus 74x equals 15x minus 60x plus 90. Now we add like terms. So we have x's on the left side and we have x's on the right side that need to be added together. That would be negative 105x plus 70 equals negative 45x plus 90. Now it doesn't matter in the next step which direction we move x. I have always been a fan of keeping my x positive, so I would add 105x to each side. However, you could just as easily add 45x to each side and you should get the same answer. Since we're moving 105 to the right, we should move 90 to the left by subtracting 90 from each side. That will give us negative 20 equals 60x. And then we divide by 60, which gives us x is negative 20 over 60, which reduces to negative 1/3. Now, if this were an SAT or an ACT question, it would be multiple choice. If it were an I-Step 10 question, you'd probably see it as a multiple choice as well. It might show up on extended response, but that's pretty unlikely. Letter F is a question that they love on the SAT and the ACT. It says, what is the value of the constant h in the equation below that will result in an infinite number of solutions? So remember that the way that we get infinite solutions is the variable drops out, excuse me, and we have what's left. So we would distribute that h, and we have 6x plus 18 equals 3hx plus 9h. So in order for this to be equal, those 2 terms have to be equal, and those 2 terms have to be equal. And if h equals 2, then this equation is 6x plus 18 equals 6x plus 18. And when we subtract 6x from each side, it drops out, leaving us with a true statement which would be what we're looking for because that would mean infinite solutions. So the value that we're looking for here is h equals 2. Okay, the other thing you're going to have to be able to do coming into Algebra 2 is you've got to be able to reorganize formulas and equations for specific variables. It's called solving a, what's the word they use for it? Solving a formula for a specific variable. I forget what they call that in Algebra 1, what the skill name is. But guys, every Algebra 1 student makes this harder than it is. We're just going to use our properties of equality to rearrange the equation and get whatever variable they ask us to solve for completely by itself. So in this first example, they want us to get b completely by itself. So to do that, we first need to get rid of the 1/2. We've talked repetitively about how to clear a fraction, we multiply by the denominator of that fraction. So we're just going to multiply both sides of that equation by 2, which will give us 2a equals b times h. Now again, the goal here is to get b completely by itself. We have b times h, so we divide by h, which gives us b is equal to 2a divided by h. For those of you that are not familiar, area equals 1/2 base times height is the formula we're working with. That's the area of a triangle. What we have just done is rearrange that equation so that now we can find the length of the base by dividing twice the area by the height. In the next one here, we're looking at the surface area of a cylinder. Surface area equals 2 pi r squared plus 2 pi r h. And we're being asked to isolate, to solve for h. So to do that, we need to treat this like a regular equation. We need to get this term that contains the h by itself. So to do that, we would start by subtracting 2 pi r squared from each side of the equation. Now when we do that, we can't actually combine SA and negative 2 pi r squared. So we just write surface area minus 2 pi r squared equals, and we still have 2 pi r h on the right side of the equation. Now there, if we're trying to get h by itself, all of this is being multiplied. So we simply divide by everything that's not h. We do the same thing over here. Everything divided by 2 pi r. Now keep in mind that the top of that is protected, so you can't go and do anything like canceling 2's or pi's or r's. That's not allowed. Okay? 2's cancel, the pi's cancel, the r's canceled. So we are left with h is equal to the surface area minus 2 pi r squared all over 2 pi r. All we're doing is rearranging the equation using our rules for equations to isolate whatever variable they ask us to isolate. That does it for this video. We have one video to go, and that is writing and solving equations from word problems.